So I think most attendees are present now. Hello and welcome to our webinar about GAMS MIRO, which is the latest product developed here at GAMS. The official release of MIRO was last week, and we are really excited to present now what you can do with it. My name is Stefan Mann. I'll be moderating this event, and our speaker today is Frederick Proske, who's one of the lead developers of GAMS MIRO. So without further ado, let me hand over to Freddie, and I hope you will enjoy the talk.
Yes, thank you, Stefan, and welcome also from my side to our webinar today about GAMS MIRO 1.0, or how to deploy your GAMS models within minutes. I will start the webinar by introducing you to the key concept and ideas of GAMS MIRO. I will then do a live demo where I will be developing a MIRO application from scratch. I will talk a little bit about the batch solve capabilities in MIRO, and will give you a sneak peek to what's about to come. What is GAMS MIRO? Well, first of all, you can think of GAMS MIRO as the face to your GAMS models. It comes with intuitive widgets that allow your end users to feed your model with exactly the data they want to. And it also comes with a wide range of powerful charting tools that allow you to visualize the results your model produces. Since you might have more than just one GAMS model, you might also want to have multiple MIRO applications. And the MIRO gallery, or the MIRO library, sorry, is the place where all those applications can be managed. So here you can add new applications, you can remove existing ones, and you can also change some general preferences. And last but not least, GAMS MIRO is GAMS's gateway for optimizing in the cloud. Now, we believe that collaboration is the key to success for any OR-assisted project, and the internet makes it extremely easy to collaborate with all sorts of people around the world. And for that reason, we have developed GAMS MIRO entirely based on web technology so that it runs on any modern web browser. In addition to that, we also developed a version of GAMS that is tailored to cloud environments so that you can run your CPU-intense optimization problems from your workstation, your tablet, or even your smartphone. So, a graphical user interface for your GAMS models, a library for all your MIRO applications, and GAMS's gateway for optimizing in the cloud. To summarize, it is a bunch of components that form the deployment environment of GAMS. Today, I will talk about GAMS MIRO Desktop, the version of MIRO that we released about 2 weeks ago, and I will leave the cloud components for future webinars. So before I go to the hands-on part, I would like to talk about two core concepts that are crucial to understand when it comes to working with MIRO. The first one is the data concept. Now, when you start MIRO, MIRO will always start out with an empty sandbox. I will come back to what I mean by sandbox in just a few moments, but for now, think of it as a container that you can throw data into. So what kind of data? Well, you can either use data from the MIRO internal database, so MIRO comes with its own data management, or you can drop in external files like Excel, CSV, or GDX files. And probably most importantly, you can also manually edit the data right from the MIRO interface. So you can change the data in the tables, or you can move your sliders around or select a different option in the drop-down menu and so forth. And at any given point, you can say that now you're happy with your data and you want to solve your GAMS model. You do this by clicking the Solve button. MIRO will push your data to GAMS. GAMS will read this data, solve your model, and produce results that are again pushed into the MIRO application. And from there, you can again either save them to the Miro internal database or export them as external files. Now, a crucial point for the communication between GAMS and Miro, for this handshake to be successful, is what we call the GAMS Miro data contract. And here on the left, you see that we highlighted some dollar control options, namely on external input and off external input. And any declarations of symbols between these two tags will be imported from Miro. So GAMS knows that these are external input symbols that it should import from Miro. And the same goes for the output. So here we have on external output and off external output. And after the execution phase of GAMS, GAMS will push these results back to Miro so Miro can read them and display them again in the interface. So I talked a little about this sandbox. So Miro starts out with an empty set of data sheets. And I already said that you can populate them from the Miro internal database, and we call these scenarios. So a snapshot of your sandbox at any given time is what we call a scenario. Now, you can also load external files, as I just mentioned. You can load attachments, so any sort of files that are not visible or modifiable from the interface, but can still be accessible to your model, and obviously manual edits. Now, GAMS and Miro always communicate with the data that's in the sandbox. So GAMS never communicates directly with the scenario from the database, but always with data that comes from the sandbox. When the results are ready, or even before that, at any given time, you can again store the current snapshot of the sandbox back into the database. You can attach some metadata to the snapshot, namely a name, so you can later find this scenario more easily, and also tags. Right. So before I get to the hands-on part, I want to introduce you to the model that we will use as the example. Some of you are probably already familiar with it, but the past weeks and months have given some interesting dynamics to this, so I will use it again. It's a model from the financing sector, and we call this pick stock. So basically, we have stock data from the 30 stocks of the Dow Jones Index. And what we want to do is we want to find an index fund that consists of a subset of these 30 stocks. And this index fund should approximate our overall Dow Jones Index as closely as possible. So we take a subset of our 30 stocks and approximate our index. Now, we all know that since it's an optimization problem, it will do its job optimally with respect to the objective function. But what we are really interested in is not how well our index fund performs on known data, but how well it does for unknown data. And for this reason, we divide our data set into two subsets. We call the subset that we feed to the model, that the model knows about, the training set or training phase. And we call the second part, subset of the data, our testing set. And we use this to evaluate our index fund and how well it performs on unknown data. Let's look at an example. So what you see here, the green curve is our Dow Jones Index, and the blue curve is an index fund that our model computed. And you can see on the left here, the part that is highlighted, this is our training subset. This is the data that the model knew about. And you can see that the area between these two curves, that's basically what we want to minimize, is very small, actually minimal in this example, for the given number of stocks, obviously. However, if we look at the testing part of the data, so the data that the model did not know about, we see that the area between the two curves is quite a lot larger. Again, what we would expect, because this is the part of the data that the model did not know about. All right, so let's get to the hands-on part. What you see here is the Miro library. You can see that I currently have 2 prototypes of my pick stock model imported here. And let's start with the first prototype. I can click on launch and the Miro interface will pop up. You can see that we have a README file that basically explained what I've just shown on the slides. So the model description here and how to use this interface. Then we have our input widgets tab. So namely the 2 sliders for selecting the maximum number of stocks and selecting the number of training days. And then we have the price data. So you can see this is a table. And if we want to look at it in a graphical way, you can switch to this chart here that shows you the data. Now, this data that I imported here is from 2016, and I promised you that I would come up with a little more recent data. So let me quickly push that in here. So here I have a CSV file with some more recent price data, and I just load that in here. You can see that the interface updates. And when we go back to our chart here, you can see that this looks a lot what we already seen in the news probably over the last few days and weeks. All right, so let's run our model. Let's select about half of our data for training and the other half for testing. And let's run this with let's say 9 stocks. We click on the solve button. You can see that GAMS runs. It computes the results. And here we see the blue and the green line that we already saw on the slide before, namely the Dow Jones index and the index fund. And the area between these two, you can almost not differentiate which is which in this chart because it's pretty small and almost negligible. Let's save this and call it 9 stocks. So I save the snapshot that's currently in my sandbox as a new scenario. I will give it a tag to say that this was data from 2020. And this was the scenario where I selected 9 stocks. All right, let me run this again. And let's say we only allow 8 stocks to be selected now. Now, obviously, we further reduce our solution space by doing this. So our solution in terms of the training data can only get worse, right? But our testing data can get better. And as we see, it actually does. So let's save this as 8 stocks. And for those of you who might remember how this chart looked like in the previous run, you can already kind of imagine that this was actually worse in terms of the error in the testing phase than this one here, where we only allowed 8 stocks to be selected. But there is a better way to compare different scenarios in Miro. And you can already probably see it here on the right. There is this compare scenarios tab. So let's load our 2 scenarios here side by side so we can really compare them one next to the other. And now you can see what I already guessed from my memory before, but now here side by side, that the scenario where we only allowed 8 stocks to be selected actually performs better than the scenario where I allowed 9 stocks. And let me also put that in numbers. So here you see the error in the training phase. The absolute error is 4.07. And with 9 stocks, it's less, as we would expect, because the model is less restricted. However, in the testing phase, we see that this scenario here with 8 stocks actually produces quite significantly lower errors than the one with 9 stocks, which I think is an interesting result. If we look at the weight tab here, you can see that actually how our index fund is composed of, what are the components of the different stocks. And you can also see that this one here consists of 8 stocks and this one of 9. Right. So let me close this, because how do we get to such an application that I've just shown you? So we start out with our raw GAMS model. This is just a GAMS model that probably most of you are familiar with. Nothing special to it. I can run it here in GAMS Studio. It comes back with the optimal mixed integer solution of 79.6. And there is nothing special to it. I read in some CSV data here. I declare my variables and equations. I set up my model and I solve it, and here I compute some reporting parameters. Now, how do we turn this into a Miro application? Well, first of all, we need to set up the GAMS Miro data contract that we've already seen. So I need to tell Miro what are the symbols I expect to come from Miro. And I do that by annotating my declaration here with these tags on external, should have deactivated caps, on external input and off external input. Now this is my price parameter, which has these cute implicit assignments of the set, state, and symbol. And then we have our scalars max, stock, and training days that you previously saw in the form of these sliders. And note also that these instructions $call, $GDX_in, and $load of this price parameter are inside my tags. So GAMS is smart enough to know that these $call, $GDX_in, and $load instructions should probably be ignored when run under Miro, because this data should come from Miro instead of the CSV file, as it does here. All right. Let's go to our reporting parameters. So here you see these scalars that I've shown previously, the error in the training phase, the testing phase, the ratio, and also some other parameters that we want to visualize as part of our results. And I also annotate these as output symbols with a similar tag on external output and off external output. And that's it. Now I basically declared my data contract between GAMS and Miro. I can still run this model in Studio just as I did before, and nothing changed in this regard, but I can now launch my Miro application for this model, and you can see that quite a lot is going on here. Miro is setting everything up, communicates the data contract with GAMS, imports some default data, and spins up the interface. Now you can see that the sandbox is now empty, and I can load some data into it. So I can click on this Load Data tab here. I can see that there is also already a scenario that was magically imported into the Miro database from your GAMS model. And if I load that in here, you can see that we have our price data in here. When I go to the scalars table, you might also notice something special here. We automatically merge all the scalars into a single table per default, so that you save some screen real estate and you don't have a new tab for each scalar here. All right, so we can maybe change this to, let's say, 10 stocks, and maybe we only want to allow 30 days to be used for our training data. We can run our model, and it comes back with the results, again, in tabular form per default. So you can, for example, look at the Dow Jones versus index fund parameter. You can filter these tables, sort them, search through them. But obviously, they are still tables, no colorful charts and widgets as we saw previously. Now, how do we set up charts and widgets then? Let's do that as well. So we go back, we close our Miro application, and we select to run Miro in a different mode, the configuration mode. So the configuration mode allows us to do all kinds of customization to the interface. So you can modify the general appearance of your application. So you can set a logo which appears up here in the left corner. or the color theme to use and so forth. What we want to do now is configure some widgets. So we select this Configure Widgets tab, and here we have the symbol that we want to configure and the widget type. So this actually looks fine already. We want to configure a slider for our max stock symbol. So we say that the name of the tab should be maximum number of stocks. That's fine. And let's choose a label. So select the maximum number of stocks. So that our end users know what to do with this slider. And notice while I type here on the left, it actually updates my live preview here on the right. So the minimum value on this of this slider should be 1. It doesn't really make sense to select less than 1 stock. And for our maximum value, we actually have something special here. It depends on the data. Like for the Dow Jones, we can be pretty sure that we will always have 30 stocks, but maybe the data is somehow missing some stocks, so it's not actually 30, and then running the model with 30 stocks would maybe produce some unexpected results. So we would rather like to have this data to be dynamic. And we can do that by unchecking this checkbox here and saying the data should come from our price parameter, and more specifically from the stock symbol column. And we want to count the number of occurrences of the stock symbol here, and then this maximum value will be set accordingly. All right, let's save this and let's do something similar for the maximum number of training days. So we again give a label, select the number of days for training. Also here, it doesn't really make sense to set it to 0, but at least we should have 1 day for training. And for the maximum value, again, we want this to be dynamic here, even more importantly than for the max stock scalar. But this time we select the date column here. And again, we want to count the number of occurrences in our data. And maybe this slider will be there's a little more values to select from. So let's show some tick marks as well here. Save this as well. And that leads us to setting up some charts. Now here, you again see this default scenario that was extracted automatically from your model, and the data you load here will actually be used for our preview that you will soon see here on the right. So let's maybe first configure a chart for our weight symbol. So how is our index fund composed of? What components does it have? A pie chart is perfectly suitable for that. Let's maybe make it the donut chart by increasing our donut hole here a little bit and save this. And now we set up a donut chart for our weight parameter. Let's do one more. So this chart, Dow Jones versus index fund, was the one we looked at most because it's pretty informative and you can see a lot of information with one look. So let's configure this one. No, we don't want a pie chart from this one, but instead would like to see it in a form of a time series diagram. So let's select this chart type here. The date should be on the x-axis, that's fine. So let's go to the y-axis. The Dow Jones is also perfectly fine. We don't need to change anything there. Let's also add another data set here, our index fund, and that's all we need to have. Now, maybe let's add one more little detail here, which is this event line. We call this event line. It marks the end of our training phase. This is a pretty informative line to draw, so let's also do that here. We select event on the x-axis here. We add an event line, and now we need to select which symbol we want to use for this event. And actually, we want to use the last date of training period. That's exactly perfectly described by the explanatory text there. And we can say that we want this to be labeled as end of training phase. Right? Top, yes, that's fine. Let's maybe make it a little more visible by changing its color to red and maybe also make it a dotted line instead of dashed. All right, so save, and I think we are good. Let's close our configuration mode here and spin up the GAMS MIRO base mode again. All right, load in some data. You can already see that we have a new tab here. It used to be input scalars, now it's input widgets. And here we see our two sliders. And you can also see that the upper bound here was automatically updated when we loaded the data. So here we have now an upper bound of 30 because our data actually is complete in terms of the Dow Jones. So we have all 30 stocks in our data set. And for this data, we have 252 training days. Now, if we look at the output, you can see that for the weight parameter, we now have our donut chart. And for the Dow Jones versus index fund, we have our time series diagram here. And this little event line here marks a point that you could almost see even without this information, because here it really starts to deviate quite a lot further. So this, we would also already have expected this end to be somewhere in this area here. But all right. So let's say we are now happy with our first prototype for this application, and we would now like to give it to our end users. How do we do that? Well, there is another tab here, another option here in GAMS Studio. It's called deploy. And what do we mean by deploy is we create a self-contained file that contains everything you need for importing this Miro application into your gallery. So your model is part of it, the configuration is part of it, and as well as the data contract. So everything is self-contained in one file, and this file is also platform independent. So you could give it to someone running on a Mac or on a Linux machine. Now, Studio gives us a little help with creating this file here. You can see that there is something called assembly file, where it currently says we don't have one, and it gives us the option to create one. Now, what is this assembly file? Well, in order for this file to be self-contained and to contain everything that's necessary to run your model, you need to tell Miro what files are part of your model. So let's click on Create here. And in this little example app, I have my Dow Jones data, this CSV file here, and I have my main GMS file, obviously. Now, for more complex application or models, you would have all sorts of include files and maybe other data files that are read during the execution phase and so forth. So this would be a lot more of files you would need to select here. But anyway, for now, this is all we need. We can click on Create. You can see that Studio now realized that it has this pickstock assembly file here. We can select what modes we want to deploy for. For now, we only want to deploy for the base mode. I will talk about the hypercube mode in a few minutes, but for now, let's just deploy for the base mode and click on deploy here. And GAMS spins up, or actually Miro spins up and produces a Miro app. You can see here in the log that it says pickstock raw Miro app successfully deployed at location blah, blah, blah. So let's open this location here. And here is our Miro application file that was just created. All right. So we have a ready deployed Miro app. We could double click it and import it into our Miro library here. But for now, let's first switch back to the slides. So typical workflows. What you've just seen is what we call the Utopia approach. You have your model, you prepare it. Basically, you set up the GAMS Miro data contract, You then start to configure your Miro application with the Miro configuration mode. And when you're happy, you deploy it and give it to your end users. This is almost never going to work like this in practice, and that's why we call it the Utopia approach. Now, a more practical approach is an iterative approach. You start developing your model and preparing the data contract. You start up the Miro application, and you use the charting capabilities of Miro to debug your model. Because why not? You see at one site when something is inconsistent in your data. It's much more easy for at least most humans to spot errors when they see a chart than seeing a table full of numbers. So Miro is helpful in debugging your model. Once you're happy, you deploy it and you give a first prototype to the customer. The customer then gives feedback, probably both in terms of the app configuration. So maybe they want a different widget for this particular scalar, or they want the order of the tabs to be different or grouped together or whatnot. And also in terms of the model. So maybe there are some important constraints missing that simplify the problem too much or something like that. So we have these constant feedback loops from the customer. Now, again, you go back to the drawing board, you improve both your model and your app, you deploy it again, and you give a second prototype to the customer. Again, you get feedback and so forth. So it's a continuous feedback loop between you and the customer until you come up with an application that's hopefully be used successfully in production. Let's get back to our example. So here you see something that we've already seen before, second prototype. So let's assume we've developed our model a little bit further. So instead of this table for the price data, we now have a chart. And we can interactively modify the data by dragging and dropping in this chart. So let's assume that we expect some pharmaceutical company to come up with a medicine or a vaccination or any sort of thing that helps heal the coronavirus. So let's select some pharmaceutical stock here and say we want to play around with this data and set up a new scenario by dragging this chart here. So let's say this one we expect to explode quite drastically. All right, and we select 35 and 5 stocks. That's all fine. Let's just run this and see what the results will be. And you can see that during the training phase, again, very low errors. During the testing phase, not so much. So let's save this and call it Pharma Explodes, right? And let's compare it. Sorry, go to the compare screen here, load the scenario, Pharma Explodes, and compare it with our default scenario where the pharmaceutical stock did not explode. And you can see, maybe not as drastically, but a little bit, this chart here, the Dow Jones index deviates even further if the pharmaceutical stock would explode. And if we look at the numbers, you can see that, well, indeed, this error during the testing phase is a little bit higher than the one in the testing phase for this default scenario. So let's assume that our customer would like to outperform the Dow Jones index. But at the moment, they don't really have any influence on what stocks the model selects. And because it's the testing phase, the model will not realize anything or will not know anything about what's happening after this training phase. But the customer would like to have a little more control over that. So he comes back to us with the request to be able to fix certain stocks that should always be included in the index fund. Right, we go back to the drawing board, we open up our model for this second prototype that we've seen. And we come here and say that, okay, we need a new set. So we declare it another external input that the customer would like to modify. We call it fixed stocks. And it's a subset of our symbols. And we give some explanatory text to it. So symbols that have to be included in index fund. And for now, let's leave it empty. We close this annotation here with off external input. And now we obviously need to do something with it. Let's copy it and right above the solve statement, somewhere here, we simply say that our binary variable P, which is responsible for whether the stock is included in our index fund, should be fixed to 1. So we say Pfx of this fixed stock subset is equal to 1. And that's basically it. Right, so we run our model. We see that we get a solution of 7.88. Now let's maybe put some stock in here to see whether something changes. And indeed, our model depends on what we select in this subset here. So let's configure a drop-down menu for it. Makes sense that you select set elements with a drop-down menu. So let's set that up by spinning up our configuration mode again. We go to the widgets here. We have this new symbol, stocks that have to be included in index fund. Perfect. Let's also assign a label. Select stocks that have to be included in index fund. Yes. Again, we want these choices to be dynamic. So we want these to depend on the data that's currently loaded. So we select our price parameter and our stock symbol column that this drop-down menu should be populated with. And we would like multiple items to be selectable so that the customer cannot only fix one stock, but multiple of them. We click on save and we are basically done. Let's spin up our Miro app again. Again, the new configuration will be applied, the interface will be rendered, and it spins up here. And when we go to our data, let's load our pharma explodes scenario again. Let's verify quickly whether the scenario was indeed loaded. And yes, that looks about what we just configured. So let's now run this where we say this PFE stock here, this pharmaceutical company, should be fixed. So should always be included in our index fund. Let's solve the model NR. For those who remember the previous image, this looks a lot different to what we've seen previously. So this index fund clearly outperforms the Dow Jones index when we compare them again side by side. So we load the active one here and we load the pharma explodes here. You can see that this has drastic consequences. The error here is a little higher, a little bigger. If we go to our output scalars, yes, now that we fixed something, we reduced the solution space, so we get a larger error in the training phase, but we outperform the Dow Jones index in this case, which was the customer request. All right, so let's get back to the slides here. Yes, all right. So Utopia approach, not going to be so successful in practice, at least most of the time. Iterative approach, probably the much better one. All right, everything that we've just seen. So this Miro sandbox that you can load some data into and you can interactively change it and start your GAMS job. This is what we call the GAMS Miro base mode. Now, what if you are interested in answering more high-level questions like how many stocks should I select at minimum before I underfit the data? Or how many training days should I pick? And obviously you could do that in the base mode, you could start and increase your number of stocks from 2 to 3, increment again from 3 to 4 to 5 to 6, and do the same with the number of training days. But this quickly becomes tedious, and we would like to have a more automated way of doing that. And so for this purpose, we have developed the GAMS MIRO Hypercube mode. Now, why Hypercube? Well, in this Hypercube mode, we automatically transform your widgets to be more suitable for batch solves. So for example, we take your maximum number of stocks slider and we extend it to a slider range. So instead of selecting a single scenario with, let's say, 4 stocks, we now select a whole range of scenarios from 2 to 10. And we do the same with the number of training days. Now, how does this look like? So under the hood, what MIRO does is it automatically generates the Cartesian product of all those ranges. So let's say you have 2 scalars here, the maximum number of stocks and the training days. So it will become a matrix, right? You have a scenario with 2 stocks and 75 training days, one with 3 stocks and 75 training days, 4 stocks, 75, and so forth. So this becomes a matrix. Now, if you would have a third slider or a drop-down menu or whatnot, you would get a third dimension. So you would get a cube and then a hypercube. And that's why we call it the hypercube mode. Now, in addition to MIRO supporting you with setting up multiple solves in a single job, MIRO also supports you in filtering the results. So what you see here is the Hypercube interface for basically filtering your database. Once the scenarios are again imported into the MIRO database, you can use this interface here to filter both based on metadata, like when was your job created, what tags did you assign to this job, but also on intrinsic data, so data that is part of your model, like say the MIPS solver here, or you want to filter only the scenarios that have a maximum number of stocks which are larger than or equal to 7. And also you can use output scalars here as well. So you can say, give me everything where the absolute error in the testing phase is smaller than 170. So then you can fetch your results and MIRO comes back with the slice of the data that fulfills these requirements. What you can do then with this slice that you've just filtered is you can push that into some sort of analysis script. In this case, what you see here is it's a Jupyter Notebook script that is displayed, like started, and the results are displayed in MIRO. So it's integrated into MIRO, even though it's an external script, and MIRO can display the results that the script computed. So for example, here you have this box plot here that tries to answer the question, how many training days you should choose, and so forth. And with that, it ends my presentation. And
okay. Well, thank you very much, Freddie. That was a great talk. I think you all agree. And we do have some time for questions. So Robin has been busy collecting questions from you, from the audience. And I will kick off with a licensing related question. So when you deploy the app to the customer, should the customer have a license for GAMS and or the solver?
For the version I've shown you today, the answer is yes. You need both MIRO and GAMS installed on your machine, and therefore also need a GAMS license for this machine. Maybe I will kind of postpone the second part of my answer a little bit to the next few slides, because the cloud environment is a little different there.
Yeah. Okay, the second question is related to your model definition. So the question relates to the parameter price, and there's the less than symbol that is used in the model definition. And the question is, what does this symbol mean?
Right, that's the so-called implicit set definition. I think we introduced that with GAMS 27 or 28, somewhere around that. And if I go back to Studio here, it basically says that my set date and symbol should be defined implicitly by my price parameter. So my price parameter defines implicitly both the elements of date and symbol.
Okay. Then we have a question. It says, is the input from Miro written to disk before reaching the GAMS run?
Yes.
Yes. Okay.
The GDX is the exchange there. Yes.
Yeah. Another one, can the input data come from different CSV files?
Yes, so I've actually shown you, so if you go almost to the beginning of the webinar where we had our first application of the pick stock model and we had the data of 2016 loaded in, I actually overwrote that data by dropping in my CSV file from 2020. So this data came from an external CSV file and overwrote what was in this default scenario.
Here's an interesting one. How much flexibility do we have to design the dashboards? Are maps possible?
Well, that's a broad question. How much flexibility? You have, I would say, lots of flexibility. I don't think that helps anyone though. Like, you can basically do anything within these tabs you saw. So the sidebar on the left where you select input, output, GAMS interaction, compare results, that's more or less fixed, but you can customize all sorts of other stuff like the appearance, the little logo, and within each input and output tab, it's basically your playground. You can do anything in these tabs, and you can also obviously change the order of the tabs and group them together and so forth. So, and sorry, the second part of the question was?
Are maps possible?
Are maps possible? Yes, maps are absolutely possible. You can find many examples for maps in our gallery. So if you go to gams.com/Miro, I think I will have the URL at the end of my talk, so you don't have to write it down now, but gams.com/Miro is the website where you will find all information about Miro. And there is a link to our Miro gallery. And inside this Miro gallery, you can see lots of examples for maps. Yes.
Okay, so maybe we'll take one more last question. Do I need GAMS Studio for using Miro?
No, you don't need GAMS Studio. We highly recommend using Studio because there's lots of graphical support, for example, for deploying your app and also for spinning the Miro interface up. But in theory, you could just as well use the command line as well.
Okay, thanks so much for answering the questions. I think we'll leave it at that. All the questions that we haven't answered now, we will collect, and after the webinar is finished, we will take some time to answer them all and send you all the questions and the answers. And Freddie now has a little announcement, so hand back to Freddie.
Right. So in the beginning, I talked about what is GAMS Miro, and I also mentioned that I will leave the cloud components for later webinars. And this is actually a little announcement. So in exactly 2 weeks, we will do another webinar on what we call GAMS Miro Engine. So what is GAMS Miro Engine? What I've talked about today was GAMS Miro Desktop. So everything was installed on your local machine. You have your Miro application as well as GAMS installed on your local machine. Now, there are 2 more setups for Miro. One is Miro is installed on your local machine, but the GAMS jobs are actually pushed into the cloud. So GAMS Miro Engine, the version of GAMS that is perfectly suited for doing this job, for solving GAMS jobs in the cloud, will compute your results and hand them back to the local application that runs on your desktop. So this is what we call Miro Desktop boosted by GAMS Miro Engine. And then we have a third setup, and this is actually the setup we also use for our Miro gallery that I mentioned a couple minutes ago, where everything runs on a server. So in this setup, You don't have to install anything on your local machine, and that's why you can also access Miro from your smartphone or tablet, or basically any modern web browser, as I explained previously. And obviously, in this setup, GAMS MIRO engine will also take care of solving your CPU-intense optimization jobs. So this GAMS MIRO engine is basically an API that goes hand in hand with Miro, so it works perfectly well and seamless with Miro Server and Miro Desktop, but it's an API, so it will also be supported by Studio. It comes with its own web interface, and you can also use this API from all sorts of programming languages like Python, Java, and so forth. And as I said, this webinar will take place in exactly 2 weeks, the same time, and we hope to see you in 2 weeks. Thank you.
Okay, thank you very much, Freddie. I think this was a great talk. Thank you, Robin, for helping with the questions. And of course, thank you all for taking the time to join us today. So as Freddie mentioned, for more information about Miro, please visit gams.com/Miro. And we would love to see you at the next webinar on the 5th of May. So take care. We'll send out the recording of this webinar within the next few days, and have a great day. Goodbye.
Goodbye.